Hey everybody, Josh Winkler with Cripple Concepts, back with another video featuring some of our equipment here at the shop. This is our Solidoodle 3 3D printer. This is the third generation of Solidoodle's printers. They've come out with a couple of new models. The Solidoodle 4 is a lot similar in size to this model. However, it comes with an enclosure, and I would highly recommend you invest in that. We've had to add plexiglass sides and top to ours just to keep the heat in while we're printing. We print in ABS plastic, and the ABS has a tendency to curl if a little cool air hits it at all. I'm going to go kind of step by step through how we set it up and run it. I'll cover modeling in another video along the way. I use SolidWorks to do my modeling in, but I'll just import a model that I'm going to print today. The software that we use for the actual running of the machine is something called Repetier Host. This is version 1.0.4. I believe there is a newer version out, but I'm familiar with this one, so I've been using it. Once you turn on the Solidoodle, first thing you do is hit connect. That will connect to the machine itself. Then I come in and I go to manual control right off and start the bed temperature right away. It takes the bed a long time to heat up. I'll show you when I switch to the camera. I actually keep a shop towel over the heated bed just to help hold the heat in while it's heating up, because it'll still take a little bit of time to heat up. You can watch the temperature go up here on the screen in two places. One right here in the little bar, and the other is down at the bottom. You can always look at the extruder temperature. The extruder's currently turned off, and the bed temperature, both in Celsius. I heat my bed to 95 Celsius. I try to keep it 95 to 100 Celsius. Then the extruder runs a little over 200 Celsius. The next thing I do is I'll go ahead and hit load and pull up the file that I want to print, which is a wheelchair business card holder. Make sure I get the right one. Got a couple different versions of some of these files. That'll pop in the file to be printed. In this case, it's already in the right position. Occasionally they'll come in and they'll be tipped on their side, and you take some thought to think about some prints on which side is best to print from. You can rotate around your view, but you can also rotate the object on the bed. Say around the x-axis, I could rotate 90 degrees. The problem would be if I did print this configuration, there'd be a lot of support material generated. Actually, for this model, I won't be printing any support material, which is a big advantage. In order to print this way, this dark area is the bed. This area in the middle would all be filled with support material. Underneath the arms would be support material. Underneath the feet would be support material, which is really not ideal. So I won't rotate that at all. I'll rotate it back to the original configuration. And by printing it from the end, you end up with no support material because it's the same shape from bottom to top when you print. So once that's in, I'll print in full scale. You can make copies. You can scale the object. You can cut them down. You can move them around. For this, I'm just going to print one object. Come over to my slicer program. I use this SLIC3R. I'm on version 0.98. You have a couple options that you can run. This has just been the one that I've had the best luck with. Currently, I'll show you the configuration here. This actually is a separate program from the Repetier, so it actually has to pull up the separate program to do the slicing. And what this does is slices the layers. It basically analyzes your 3D object and cuts it at each layer and creates the G code to be used to print it out. The slicer software here, it's got a lot of options. In the print settings, I set my layer height to 0.35 millimeters. That's fairly coarse, but For most of what I do, that works. I do some perimeters to just get the extruder flowing. Do 3 solid layers on the bottom, 3 on the top to make sure the ends are sealed up. A couple of the other important things are the infill. Currently I'm on the 20 infill, which is what I'll actually print this at, because I want it pretty hollowed out on the inside to save material and keep it lightweight. So the fill density is 0.2 for 20%. I choose to use a honeycomb pattern on this. You can do rectilinear and concentric. The honeycomb for an object like this where there's some pretty big spaces inside, it makes a nice solid stiff structure without using too much material. Top and bottom layers, I use concentric usually. It's not quite as nice or quite as strong as the rectilinear can be, but it looks prettier, so I tend to use that. This is infill every layer. I wouldn't want to skip layers. Solid infill every 12 layers, just to help make sure everything stays solid and stiff. I'm filling at a 45-degree angle just because some of my lines are straight, horizontal, and vertical. That kicks things just a little. Sometimes I'll do 30 degrees. The solid infill threshold, this you have to play around with based on your individual part. On this one I'm running 30 millimeters squared. Basically anything smaller in area than that, any areas than that will be solidly infilled, which will make sure it's strong. Again, you learn that just playing around. Speeds, these are pretty much all the default speeds for the machine. I haven't really played around with those a whole lot. I was pretty successful with those. I do slow the first layer speed down to 45% to make sure I get a good adhesion of the plastic to the platform, because the ABS tends to not like to stick real well to the platform, and so run a little bit slow, make sure that sticks. The skirts, it does a little basically a line around the outside of where your part's going to be. I like to do that just to get the material flowing well before it starts my actual print. Support material, again, this one doesn't actually have any support because of the particular object, but again, you play around with this based on your model. You can space it out. The wider the spacing you can do, the easier it is to break off, but also the more chance of having droop in between. So it's kind of a learned based on the object you're doing how precise it needs to be. You can also use rectilinear or honeycomb. On that, I tend to use rectilinear because I find it a lot easier to break off. Same with the pattern angles. Sometimes it's better to put it at an angle, makes it easier to break off or a little stronger. I don't have multiple extruders or anything like that, so I don't worry about any of those settings. Filament settings, I'm around 1.75 millimeter filament. The extrusion multiplier, this I had to play around with a lot when I first got the machine. I learned that 0.65 worked well for me. In theory, that's actually really low, but for whatever combination of settings I'm running, that works well to get solid layers and not get any gaps between layers. Here's where you set the temperature for the printing of the filament. I run 210 Celsius for the extruder, 96 on the first layer because that's about the hottest my plate likes to get, and then I set it to 99 for the other layers. It has to get to 96 before it'll start the print, and then it tries to keep it up at 99 for the rest of the layers, and that will keep it between 96 and 97, which is just hot enough to keep it adhered. Any kind of cool air blows across it and the part will pop off the bed, and when you're doing a long print, that is quite frustrating when the part comes loose 3-4 hours into a print. Cooling, there's a fan on the extruder, and this is just some of the settings on that. Again, I've left those to the default settings. Too much heat hasn't been too much of a problem for me. And then the actual printer settings themselves, these are particular to your printer, to the size and the layout of your printer. There was a default file that came with the Solidoodle that automatically put all that in, which made my life a little bit easier. So I go ahead and shut that off, and I'm actually making changes, so I'm gonna discard that. I'm going to choose to go with the 20 infill, which is a 20% infill that I was just showing you. And go ahead and hit slice with slicer. And depending on the object, the size of the object, the complexity of the geometry of the object will all factor into how long it takes to slice. In my experience, this part takes, I believe, a minute or two to slice. You'll see the little progress bar will start extending out once it starts making some progress on it. And meanwhile, the bed just continues to get warmer and warmer. We're up to 84.3 degrees, which a lot of times by the time I'm done setting up the part and slicing it, it'll be ready to print. So I'll go ahead and I'll check the start job after slicing is finished and let the computer continue to chug away here at the slicing. We'll throw this up on fast forward for a second until we jump ahead to the finished slice model, and then we'll show you how the print begins. As you can see, this slicing is continued. Now it's generating the perimeters. It goes through a few steps here, and then the slicing will be complete. And as soon as the bed is up to the 95 degrees, or 96 degrees Celsius actually, the print will begin. And at that point, you'll see the platform that's currently in the lowered position move up. And once it goes up to the 0 height, the extruder begins to heat. Once the extruder's hot, the actual print begins. You'll also notice the paper towel over the print bed that I mentioned earlier. I tried hairspray. I tried washing the print bed down really well. I tried pure alcohol. I tried lots of things to make things adhere. The best solution I found, at least for working with ABS, has definitely been to use the paper towel and get the heated platform all the way hot. Without doing that, the parts would not adhere. I tried a couple different kinds of paper towels and stuff. The best thing I found was just the blue shop towels. They're cheap, they're easy, and they actually insulate fairly well. Once the platform moves up, I will actually pull that paper towel off. That way it doesn't hit the molten plastic at all. Where our slicing here is almost done. You see it says detecting solid surfaces now. That's where it makes sure it fills all the faces and everything. Anywhere there's solid surface, it should totally seal in. It goes through the layers now, infilling the layers with the honeycomb pattern. It's getting close to finished up here, and the bed's almost up to temperature at the same time. As I said, that tends to work out about the same amount of time that it takes to heat up as it does to actually do the processing with the slicer. Okay, the slicing is just now finishing up. It's exporting the G code just to the folder where it will actually run the G code from. As I said, with the checkbox there on start job after slicing is finished checked, it will immediately start the G code, which will mean that it is the first thing it'll do when it does that is try to set the bed temperature to 96 degrees Celsius. And we're sitting at 93.6 degrees Celsius now, so it won't have very much to warm up. As soon as the platform moves, I'll know that the bed's up to temperature, and I will reach in and pull the paper towel out that is currently covering the bed to help it heat up faster. My shop is at about 72 degrees right now. I do find that if you get too cool, I have to actually wait in the morning on cold mornings until I get a little heat in the shop, because anything under about 68 degrees, I have a lot of trouble with parts actually adhering to the bed. So it's important to keep the ambient temperature warm enough. Printing in the summer is definitely a lot easier than printing in the wintertime is. So now the job has actually started, and you can see the options up top here have changed to kill print and pause print. If you have to adjust a kink in the filament or anything, you can pause the print. If you hit kill print, it stops the print, and you'll have to restart it from scratch, scraping off anything you've done. The preview tab here will give a idea of how long it's going to take. This is a 5-hour and 41-second print, 252 layers. My Cam Studio popped up here. You can see the texture has changed here. This actually shows the path that the extruder will be taking. You can see a little of the honeycomb up here in the head area. You won't actually see that in the end. That's all internal, but you'll see that during the printing process. The little line around the outside, this is the skirt we talked about that gets the flow started. We just hit 96 degrees, and now the print head moves out of the way. The print table starts to come up. I'm going to pop the front door open that I built. Just slide out the paper towel that's in there. Lay that to the side. Close the door back up. Keep the heat inside. And now it will heat up the extruder itself that's currently at 25 degrees Celsius. Once that reaches 210 Celsius, the print will begin. I will go ahead and speed up the camera again here to jump to where the temperature gets up to 210, and then the print will begin, and we'll show you a couple layers at the beginning, and then kind of as the model prints up, how it all just moves. The print platform moves down 0.35 millimeters per layer, rather than a lot of standard CNC machines will move the opposite, where the head itself will keep moving up or down. In this case, the head is on a fixed XY plane, and the table itself moves down a little with each layer. That's the more common way with the 3D printers, with the additive manufacturing versus subtractive manufacturing, that they're set up. It's easier to move the platform than it is to move the head in the vertical direction. So the first layer has begun. This first time around is just the skirt material, and this just gets the filament flowing real well, gets any excess off the end of the extruder that was dangling, and gets you a nice clean start. So this first layer is a nice solid layer that really sticks well to the bed. I picked a nice long print to show off today, so it's once this first layer gets going, we'll do a little fast forwarding so you can see the layers as they happen, and then we'll try to get you a shot of what the finished part looks like. Thanks for watching, and any comments you have, any questions, you want us to do future videos on this, or have some specifics on some of the other machinery, drop it in the comments or shoot us an email. And always feel free to check us out on the web at crippleconcepts.com. Thanks for watching. Okay, we're about 2 hours or so into this 5-hour print. Just wanted to show everybody what the honeycomb pattern looked like on the internal layers. You can kind of see the gaps in there. That's actually all laid out in a honeycomb pattern. Kind of hard to get a shot. That's probably the best we're going to get. And then, as I showed earlier, every 12 layers it does a solid layer, which makes it nice and stiff and solid. And for this particular thing, it's just a business card holder. That's not a real big deal, but for other objects, that's a whole lot more important. You can actually see it's not lifting at all from the surface of the Kapton tape there. That orange stuff is called Kapton tape. That helps it adhere. It's not sticky or anything. It just must be a porous surface. That's what most of the 3D printer manufacturers send with it or recommend. Sometimes you'll see on the edges it'll start lifting off, and that's when you start to get a little nervous that it's going to lift. But this one's staying nice and solid. Temperature's been staying consistent here in the shop. I'm not going to bother showing you the end of this because it's, you know, basically what you're seeing here in front of me. This red one is a previously printed model. Those two black things are bungs for the USB chargers that we sell. They're just done in black. I'm going to turn the finished model here a little bit so you can kind of see what the end product looks like. That's ultimately what we're going to end up with here with the blue one. You can see we actually have the crippleconcepts.com right into the little fella's feet there. I don't know how well you can see on the camera. There it goes. Kind of nice as a little advertisement, but when they take 5 hours, you don't print a whole lot of these. I also want to show you the material rack that I built. The Solidoodle comes with just a plastic PVC single roll of filament rack on the back that I thought was quite terrible. So having a nice tubing bender, I bent this nice one up here. It holds 4 rolls of filament, and then there's a guide. If I can get an angle here, the guide lets each filament come through separately, keeps them from tangling up or anything. And then in between each roll, there are pieces of plywood. You can see the one on the end here. I have them as spacers. That way, when, say, the blue roll is unreeling, it doesn't unreel the red reel, and vice versa. This has worked out quite well. It keeps it from tangling, makes it real easy for me to independently change the filaments. So, yeah, I recommend building some kind of a better filament guide. So, yeah, we'll call that a video. We'll keep printing here for the next few hours. I'm going to go in and have some dinner and come back and hopefully have a finished print in a couple hours. So thanks for watching, and stay tuned for future videos on the rest of the tools around the shop.